Hello, let's continue our Sudoku adventure with Keeping the Party Lit by Gene. So this continues our shaded theme week, where we are taking some amount of shading in addition to the Sudoku. And so the shading is part of the solution, not just an encouragement. You must shade. All right, and so this one incorporates lits, which is its own, it's actually a pretty popular pencil puzzle. You may enjoy it. You can look up solving lits puzzles online. I'm sure you can find them. PuzzleLink is a good resource to finding all sorts of pencil puzzles. All right, so let's go over the rules. We do have a regular 6x6 Sudoku rules. So in each row, each column, and each bold outlined region, we are placing the digits 1 to 6 exactly once each. We also have lits rules. These are the standard lits rules. So if you're not sure, you can always look up other resources for how to play lits, and they're going to be the same. But we did our best to put the rules into here. So what we're doing is in each of these regions, we are shading exactly one tetromino. So we're shading 4 of the cells in the region. So maybe these 4, maybe these 4, maybe these 4. Let's say we shade these 4. That means the other 2 are not shaded. All right. And all shaded cells in the puzzle are orthogonally connected. So if we were to do like this, this yellow and this green tetromino would end up having to connect in some way eventually. All right. Now, what is a tetromino? I guess I should explain. So whenever you do four cells that share an edge, you have formed a tetromino. And lits is named after the 4 that are present in this puzzle. So one of them is missing, and we'll explain that in a second. But there is the L tetromino, which looks like this. But remember, any rotation or reflection of it is the same tetromino. So all of these are L's. Including, you can also face up, right? There's 8 ways to rotate reflect, essentially. So that's the L. And then we also have the I, which is just straight up and down. And then we have the S, which is everyone's favorite Tetris piece. And then we have the, oh wait, I missed the T, sorry. T is next. Anyway, here's our T. So let me make it blue. I like blue better. All right. So we have L, I, T, and S. And so there is also the block. This one is disallowed in this puzzle because of a different rule. So you're never going to have that one. All right, so we need all of them to connect. No 2x2 area of cells in this puzzle are shaded. So I can't even do something like this. I can't do an L here and an S here because this 2x2 ends up shaded. So that's disallowed. And in addition to that, no 2 copies of the same tetromino touch, counting rotations, reflections, that's the same. So if you use a consistent color for each tetromino, that's helpful because then you would notice that, here, like this. We break the 2x2 rule, but we also break the L's touching each other rule. So by making both of these green, it's clear that we have 2 greens touching across a border, and that's not allowed. All right, so hopefully that's clear with lits. We also have projected sums, so that's these clues outside the grid. And they just give the sum of the digits in the shaded cells in the row or column. So if I were to have, say, an L tetromino here, and then maybe this S tetromino here, and we look at this row, that would mean these 2. Maybe I need something here as well. I can't actually do this, but I'll do another L there. Then these 3 would sum to 16. I don't know, 16 is pretty big, but you get the idea. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. In fact, 16 is very big, so why don't we start there? There are other ways to start. I think there's a lot of stuff you can do just with lits rules, but I'm curious about this 16 because the entire row adds to 21. So thinking about the outies can be helpful. So how much is missing from 21 when we do 16? Well, it's 5. So there's going to be the unshaded cells in this row are going to add to 5 in some way, which means either a single cell that's 5 or 2 cells that are 1, 4, or 2, 3. So there's only 1 or 2 cells missing. I don't necessarily know which 2 though, so I guess we'll have to come back to that. I wanted to think about it though. We know that there's at least 1 unshaded in this 2x2 area in this guy here. So we can't use all 4 of these. So this is always going to be shaded. I'll use green. I don't know what shape it is yet. We could do a T, we could do an S, we could do an L, but this one's definitely shaded. Now here, we're going to be going in a straight line. So notice of all of within all of these, in fact, if I give them all a different color, it becomes much more obvious maybe. These are the three. We are going to have an L, and all of them will use these two cells. So I'm going to just designate purple is L. I'm going to use green for I'm not sure yet. But we know this is an L, and we'll call that purple. And it's going to either continue here or like this, but we don't know. Which means both of these are not shaded. So this cannot be shaded, because if it was, we'd have to continue here, and then that would make it 2 by 2. So we're going to start at least here, but we can't do this either, because we know this will have an L in it. This is an L, this is an L, this is an L. So because this only has L's in it, and it's definitely going to touch this cell would force an L, and we can't do that. Okay, and that means that this is an L, because it only has 4 cells left. And so now we can't start here. That would make a 2 by 2. Let's see, in this region. What's this region going to be? Not an L, but it's not in any danger of being an L. It's probably a T. Could it be an S? I don't know. I think it's always going to be a T. That's interesting. Yeah, I don't see a way to not draw a T. So this is going to have a T in it. Let's see. So that means this can't be a T. So we are not taking this cell. Interesting. Right, because if we take this cell, oh no, it could be an L if we take this cell. Never mind. I was thinking it would have to go like that, but that's not true. Now this block here, I don't know, do we need to start thinking about our projected sums at this point, or? There's 11 in this row. 3 cells can add to, so 2 cells can add to 11. We can do 5, 6. So we don't need that many cells to add to 11. What are we doing here? We know if this is an L, it's not doing this because it touches this. You know, it would touch here. It would touch the L. So can we use this cell? Yeah, we could make like a T or something. Okay, what about here? So let's highlight all the possibilities here. I'll make this red. I'll make this yellow. I'll make this blue. So I think we always use these two. Yeah, so maybe another way to think about that is if we were to omit this one, then there are not 4 contiguous cells to use. So this is definitely used. I'll just pick another color, like orange for this guy. And then this one also has to get used, because if this was gray, we could only do 3 here and 2 here. So these two are definitely shaded. I wonder if the 6 is interesting. We can only have 3 of these cells shaded. I think, do we need to shade one of these two? Yeah, we have to shade at least one of these two. If they were both gray, then we'd have a 2 and a 2, right? I mean, yeah, we're going to be omitting 2 of these cells, but not the 2 middle ones. Now, can I omit just this cell? Yeah, easily. I could do an L here. I can't do this L, interestingly. It would actually force this L. Can I omit this one? We'd have an, oh, so if I omit this one, we have an L like this or an L like this, neither of which are allowed because of the L, in this region. So I can't omit this cell. Oh, interesting. Is there any other shape? No, it's just, it's a straight line. So we're either like that or like that. And we can't be an L like that. We can't use this cell as part of an L. So this is shaded. Let's make that yellow. I'm just going to keep using green for, I don't know. I think that's better. So far I just have L's. This one's going to be a T. Oh, and it's going to use the middle cell for sure. So let's pick orange for T. Just because it's the next color. And we're just omitting one of them. Any one of these could be omitted. And when it is omitted, we will form a T with the other 3. Okay. But with this shaded, I think this could be shaded. Yeah, we could make like a T like this. But we can't shade both of these, because if we did, we would have 4 shaded cells trying to add to 6, and that's too big. So actually this has to be unshaded, which makes this one shaded. So now I don't think we can do an L at all, because we know this is shaded. We'd have an L like this, which touches there. Actually, is this L just possible? It might be. Now I don't have to shade this one. if I didn't shade this one, actually, then we would have to connect somewhere in here. Oh, with this is not shaded. Oh, I think that might help quite a bit because this is a 2x2. So we're avoiding this 2x2, and now if this was purple, I would need, I think I'd have to do an S here. Or I could do a T. But yeah, I mean, what I'm saying is if this was purple, this would be gray. This tetrameter would have to connect somewhere, and the only somewhere it can connect is here, so it would make that green. That's really all I'm saying. And it wouldn't be an L, so we couldn't use this cell, right? That's the consequence. Now, if this was purple, we don't quite have the same consequence because we can connect to this guy instead as an S, I guess. So, I only get one more shaded in this whole column. So if we did a T like this, that would make this gray and that gray. And that doesn't work. Okay, so if this was orange, right? Now I've hit my max of 3 cells in this column to sum to 6. 1, 2, 3, 6. And so the rest of that would be gray. And so this would have to be purple. And remember, the purple has to connect to this guy, and it would connect an L to an L. So that's no good. So this cannot be orange, which means the rest of the region is orange. So we have our T tetromino here. And so now this can't be a T tetromino. I don't know how to mark that, but it can't be. Let's see. So we have our four cells are shaded, adding to 11. I know the only way to do that is 1, 2, 3, 5, and we're missing the 4, 6. Basically, we're missing 10, so the outies are going to be 4, 6. That's another way to think about it. But four cells, no matter what, have to be 1, 2, 3, 5 if you want to hit to 11. 1, 2, 3, 4 is 10. We have to add 1. Only digit we can add 1 to is the 4, so we end up with 1, 2, 3, 5. Not that that helps too much right now. Let's see. So this 11 could be a 5, 6 pair here. That's the problem. But if I shade this, we have to go L. We can't do a T against the T. Oh, only one of these can be shaded anyway because we can't form a 2x2. So 2 reasons we can't make that T. But I don't really see an issue with doing this. Oh, wait, hold on. We can't make a 2x2 here, and we can't make a 2x2 here. So this is an I. Let's use blue for I. That's fun. Now 13, the outies are going to be 8. So the outies can't be 1 cell. The outies have to be at least 2 cells. So these are both gray, which finishes this as an L. That's a purple. Okay. Now this right side has to connect to the left side. This is all connected. Oh, this is going to be gray, and so that makes this a T. So that's orange. The only thing I'm missing is I'm not going to get an S in this puzzle. Oh well. So I can't connect this L to this L, so I'm going to have to connect this L to that T. And now I'm shaded. Nice. Okay, so projected sum. So we know the outie is a 5 for this guy. So that just that's all we need from the 16 clue. That's done. This is not a 5. Now we know these add to 8, so this is a 3. Keep cleaning that up. 2 cells adding to 11 is a 5, 6 pair, so that's 6 and that's 5. All right, 5 in this row can only go here now. These add to 9 without a 3. So we can't be 2, 3, 4. So we have to include a 1. And then now we need 2 cells that add to 8, and we can't do 3, 5, so we're going to do 2, 6. So this has to be 1, 2, 6. Yeah, a 9 in 3, missing the 3, has to be 1, 2, 6. Because it can't be 1, 3, 5, and it can't be 2, 3, 4. And that makes this a 4, 5. This makes that a 4, 5 pair. So that's 4 and that's 5. Yeah, and the other way to think about it is these 3 add to 12. But with a 3, you need 9 more. And you can't do 3, 6. So that would be another way to think about it. This is just going to be 1, 2, 4. Let's see, what sum haven't I thought about? I did this 11. I did this 11. I did this 9. I did this 16. I have not done this 11. So 11 and 3. We already have a 5 as part of our outies, so it might be easier to think about the outies. The outies are 10. So this has to be 4, 1. There we go. That's a 6. That is not a 6. So That was the 11. We have this 6, so these are 1, 2, 3. It's not a 1. That makes this 4, 5, so that's a 4, that's our 5. So remember, we have the irregular regions as well. So yeah, we have 1, 2, 4, 6 here. We need 3 and 5. This 5 tells us that's 3, that's 5 for that region. It's hard to see the regions now that I have all the coloring, which is a little different. But 1, 2, 4, 6 left here. I don't know if I want to do that. What else haven't I looked at? The 6 and the 13. Okay, I think I've done every projected sum. So I think it's Sudoku at this point. 5s look almost... Oh, 5s are done. That's why they looked almost done, because they were completely done. That's a 2 to finish the row. And then in this region, that makes this a 3. That does look up. This isn't 3. So that's a 1, 2 pair in this region. So we need the 3, 6. And so then we need 1, 2, 4 here. Oh, and this can't be 2 or 4 because of the region. Wow, okay. So that's our 1. That's 6. We get 2 and 1. We get 4 and 2. We get 1 here. 2, 3. Oops. So we're left with a 1, 4 pair here. Up here we get the 3, 6 resolved. We have 1, 4, 5, 6. We need 2, 3 here. This is 3. This is 2. This column finishes with a 6. This column finishes with a 4, giving us 1 and 4 here. We'll finish the row with a 2. And then last 2 digits are 1 and 6. Like that. All right. Cool. Nice puzzle, Gene. I don't do lits very often, but it is a fun pencil type for sure. And I believe most lits puzzle, you just get the regions. And so I'm sure there's variants just like any other puzzle, but in standard lits, you just get the regions and you have to figure out a unique way to color tetrominoes. So you don't get this sort of projected sum helper there, or the digits trying to help you. Anyway, let me know how you did. If you enjoyed this, why not leave a like, subscribe, and a kind comment below.